In this exercise, we're going to practice identifying observational studies and experiments, and I really recommend that you go through and do it first, and then come watch the video with me to make sure that you understood it correctly. The instructions say, determine if each study depicts an observational study or an experiment, and whether causation can be concluded. Number 1 says rats with cancer are divided into two groups. One group receives 5 milligrams of a medication that is thought to fight cancer, and the other received 10 milligrams. After 2 years, the spread of cancer is measured. So notice that we applied a treatment. We did something. So they gave 5 milligrams to one group of rats, gave 10 milligrams of the medication to the other group of rats. They did something and then measured the results. So this is an experiment. However, it doesn't have random assignment explicitly stated in the problem statement. So if we wanted to conclude that the treatment applied, the amount of the medication that was applied, caused any difference in the spread of cancer, we would have to have random assignment. And missing that, we cannot conclude causation. If we don't have random assignment, then our two groups may not necessarily be the same when we have confounding variables there. And so we don't know that the difference is due to the individuals in the group being different, or if the difference is due to the treatment. So random assignment allows us to have groups that are the same on all these other characteristics. And the only difference would be caused by the treatment applied. Okay, number 2 says conservation agents netted 250 largemouth bass in a lake, measured their length, and determined how many were carrying parasites. So you can see we have two variables being collected here. We have the length of the fish, and then we have whether they had parasites or not. This is an observational study. We didn't apply a treatment. They didn't give them more food to increase their length or give them some kind of parasite treatment. Like nothing happened. They just picked them up, measured them, recorded some variables on them. So this is an observational study. So even if we found some statistically significant relationship between the length of the fish and whether they had parasites or not, we couldn't conclude that length causes parasites or vice versa because this is an observational study with no treatment being applied. Number 3 says 7th grade students are randomly divided into two groups. One group is taught math using traditional techniques. The other is taught math using a reform method. After 1 year, each group is given an achievement test to compare proficiency. So here we definitely have an experiment where we have a treatment applied, being taught math using traditional techniques or being taught math using some reform method of teaching. So we have an experiment here. The treatment applied is the different type of math teaching that they received. And we have random assignment to the two groups. So because we have random assignment, then if our test shows that there is a significant difference in the achievement, in that response variable for these two groups, then we could state that it is because of the treatment applied. So we have random assignment. Which means that we do have the potential to draw a cause and effect conclusion. All right, finally, number 4, it says a survey was conducted asking 400 people their gender and the question, do you prefer Coke or Pepsi? They are just talking to people that they see and collecting information from them. This is an observational study. So even if they find some relationship between gender and their choice of Coke or Pepsi, then it cannot be concluded to be a causative relationship because there was no random assignment. I can't even quite envision what random assignment would look like in this place, right? They're just measuring characteristics and opinions of people. So this is an observational study and we cannot determine causation.